Hello, I'm Pedro. I'm here with Daniel, and we'll start by briefly explaining the assignment 1 of the computer applications course, in which we will store, parse an XML file, and then compute its corresponding Y matrix. So here we have our run file, which is our main file, and now what we're going to do first is initialize our database inside the Java. So what does this database comprise of? Grid data. It's simply a set of array lists of all the equipments required to compute the Y matrix and the ones that are required for us to do from the project description. Each of them have a different class, are array lists of different classes, which will be explained afterwards. And yeah, so this is our database of Java, where we store all the information from the XML files. Now we have file specifications. File specifications is simply two array lists of strings which define the tag names of the equipment that we want to read from the XML files. As you can see here, firstly, this is for the EQ file, the equipment profile, and here we have the all the tag names of the equipment we want to read. And then we also have some SSH files. So going back to run file, we'll start now with a parsing.
Okay, and parsing an XML file into Java and getting a database out of it, we have to first of all to import a couple of Java methods. Well, first like the document builder and the second one document builder factory. So to start parsing, we have to call the file names. The EQ file and SSH file, then build a new instance, build the file itself or read it, and then start parsing it and parsing the two files and then normalize it. By normalizing it, we have our data tree, which we need actually to extract the elements out of it to use it or to save it in our database. So to extract an element, for an example, we'll go through this list that was described previously. By using the tag name, we get a node list out of this element tag name, and going through this class, which we used to get the elements and node childs and other things. First of all, for each element we have a for loop that loops through that node list. So let's say with the tag name base voltage, we use this for loop, and then we go using the node list. We go through this method to extract each element and other sub elements or childs, and then we save it in a structure. For each element, we have different class. For example, let's say the base voltage as a class. We have the IDF or the name, or sometimes we could have a double or something. So after having these things stored inside the base voltage, we get it inside the list that we initialized before to have our own data structure. And now by parsing all the files, we need to start building our bus topology.
So now we're going to build this bus to branch topology. We use this data, this relational database to to parse and organize the information we want in order to make it easier for us to compute the Y matrix. So let's start by seeing what the bus to branch topology really is. So we have the class here. We have two array lists once again of bus topology class and branch topology. So what we want to define now is the bus and the branch topology to make it easier for us to build a Y matrix. Starting with the bus topology comprises of a bus bar and a voltage level, and then we have some additional equipments that might or might not be present in the bus, which are loads, shunts, and synchronous machines. This is our data or our structure for the bus topology. And then we have the branch topology. The branch topology is the remaining equipment. So it will be comprised of a list of breakers, and then we have some bus topology elements as well, because this branch topology will be connecting two bus topologies. So here we don't require to make an array, but it's a set of two bus bars, the first one and the last one, so in the beginning and the end of our branch. And then we have a power transformer or a line or both. So having defined what our bus topology and branch topology is, we are going to start by adding them to our data structure. So we first initialize them, and then we're going to put the required data that we want based on the information we got from the parsing. So starting from the method called add all bus, what we define is we go through all the buses and we store them into the bus topology, the according bus topology, and then we go through all the loads and all the linear shunts, all synchronous machines, and lastly all the voltage levels, and store them in their corresponding bus bar. So bus bar will only have one corresponding voltage level, and we will compare these elements that we got from the parsing and find the corresponding equipment for this bus bar. So having defined all the buses for our bus to branch topology, now we're going to start by building up our branches. And branches, we're going to use the method add all branch. So once again, we will start by looping all the bus bars and finding the node connected to the bus bar. So we're going to find the terminal of the bus bar and then the connectivity node which contains this terminal. And the initial iteration will simply be, we'll start by looping all existing terminals of this node while ignoring loads and shunts, because when building a branch, as we've seen before, it only contains breakers, power transformers, line and bus bars. So the shunts and the loads which are included in the bus topology do not need to be studied here. So while looping through each of these terminals, first we are going to check if it is the equipment that we want, which is a breaker, transformer, or a line, as mentioned before. And now we're going to check if this terminal has already been visited. So in other words, if this branch has already been built. But let's start by the case in which it has not. So now we'll go through this loop here. We start by initializing our branch, and we can store straight away the bus bar that we're iterating here in the beginning. So we start by building our branch and adding one of the buses, the first bus from where we start our algorithm. And then we go to the add connectors. Well, what does the add connectors do? It simply adds all the remaining terminal, possibly existing breakers in this branch, lines and transformers. And then we're simply going to add it to our bus branch topology, or just simply our branch bar array or list. So let's go a little bit more in depth into the method called add connectors, which is a recursive function. So its main objective is to loop through terminals and loads and equipments, starting from a certain bus until it finds a node connected to another bus, and then it force exits the loop, having built the entire branch. So we're going to have all the components in between these two buses, while every time we go through one equipment to another, we'll loop through certain terminals and then we will visit them using this function. We simply, our terminal class has defined bool variable, which is simply if it has not or has been visited before. So once again, we will start by first, let's search for breakers, line, power transformers, and AC line segments. Get their terminals, and go to the next connectivity node, search once again for the terminals, and loop until we find the bus, a bus connected to a node, and then our algorithm is forcibly stopped. So this is how we build all our branches in case they have not been visited before. So now that we have defined how to build a branch, we have to study the case in which we start in a bus, but it already has a branch connected to it. So the terminal of a breaker of this equipment that might be connected to this bus has already been visited. So what we have to do is access that already existing branch and add the other bus bar. So having defined all these methods, we now have the required structure for us to do our Y matrix.
So to start building the Y matrix, first of all we have to initialize our variable of the Y matrix, which is basically a variable of it's a matrix of 2 dimension of a complex number. And basically what's a complex number? It's a structure that we build to define our complex number with the real part and imaginary part inside it. And here in this class we have different methods that we need to use for complex number, let's say dividing or adding. And also we have methods to calculate admittances of load, shunt, transformer, or line. All of these are going to be used to be added to the Y matrix. So by initializing the Y matrix, now we have to build it. So building the Y matrix, there's something that we need to do in the very beginning, which is checking the status of the breakers. So if the breaker, for an example, is not connected, it's open, then we have to exclude the branch that is connected to that specific breaker. Otherwise we build our own grid, and going through this now we have the grid, so we can basically build our Y matrix. So to build the Y matrix, there's 2 major components, the diagonal one and the others. So to build the diagonal one, there is 2 main things, either the load or the shunt that are connected to it, which will be described here, or the transformer or the line that connects the bus bar to others. So to go through the loads or the shunts, first we have to go through each bus. By going through each bus, we know which one has load or shunt or both or whatever, and then we use those functions that was previously referred to inside the complex about computing the admittances of loads by using the power and the reactive power and dividing the voltage squared to the power, or doing the same for the shunt. And then by building the first part of the diagonal part, we have to go through the other parts of the Y matrix. So to do so, we have to first get the index of bus bar, see how is it connected to the other bus bar, either through a transformer or line or more than one of them, and then get the index of the other bus bar and calculate the impedance or whatever the element that connects them, and save it inside this Y index of the first one and the second one. By doing so, we get the elements that are not in the diagonal, but we also need to add this to the diagonal part, to the loads and to the shunt. So we basically do the same, but without the negative signs of these other elements of the Y matrix. By doing so, we actually get our Y matrix. So since we have stored our data, used them to build or to get our topology and to build our grid, and now calculate the Y matrix, so now we can basically run our file to show some of our outputs like the Y matrix and other stuff that we thought might be relevant. Thank you.